Welcome. Today is part 8 of binomial theorem. First problem is problem number 36, and it is the term independent of x in x square minus 2 plus 1 by x square to the power 8 is options 8c5, 8c4, 8c8, 16c8 and 16c9. Question is very simple. One expression is this: x square minus 2 plus 1 by x square, this to the power 8. We have to find the term which is independent of x. Independent of x means in which term there is no x. That is, power of x is 0. That is, x to the power 0 is present. Now to solve it, it can be written as x minus 1 by x whole square. This one is x minus 1 upon x whole square whole to the power 8. 16. In that, it is a binomial. Its first term will contain x to the power 16. After that, each subsequent term, power of x will be decreased by 1 and 1, that is 2. So next term will contain x to the power 14, then 12, then 10, then 8, then 6, then 4, then 2, after that 0, then minus 2. So x to the power 0 means this term is independent of x. So it is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So ninth term of that is independent of x. So independent term is ninth term T9 16C8. So 16C8 is the term independent of x in that expansion, means in that expansion. So our answer is option C. Next. Next problem is problem number 37 of that chapter. The problem is sum of coefficient of x to the power 12 and x to the power minus 12 in x square minus 1 by x square, this to the power 12 is options minus 2 into 12c3, 2 into 12c3, 0 and 12c4 plus 12c6. Now the question is, we have to find the sum of coefficient of x to the power 12 and x to the power minus 12 in that expansion. So you see, first term will contain x to the power 24, because x to the power 2 whole to the power 12, x to the power 24. and after that all subsequent terms, the power of x will be decreased by 2 plus 2, that is 4. So next term will contain x to the power 20, then x to the power 16, then x to the power 12, then x to the power 8, 4, 0, minus 4, then minus, it is minus 4, then minus 8, then minus 12, then minus 12, then minus 16, and so on. We have to find the sum of the coefficient of x to the power 12 and x to the power minus 12. Now, first term will contain, you see, x to the power 24, first term. Second term will contain that. Third, fourth term will contain x to the power 12. It is fourth term. T4 will contain x to the power 4. Now it is 5th, 6th, 7th, 8th, 9th, 10th, 11th, 10th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10th term will contain x to the power minus 12. So we have to find coefficient of T4 and T10. Now coefficient of T4 is equal to, binomial is this, 12C3 into x squared to the power, actually x we have not to count x, but actually it is x to the power 24, I mean it is 9, 18, 19. So, but one negative is there, you see, negative because of that fact. It has minus 1 to the power 3. So it is minus 12C3. Now coefficient of T10, it is equal to 12C9 into, this is one coefficient, 1 to the power 3 into minus 1 to the power 9. So again it is minus 12C9. 12C9 is nothing but 12C, 12 minus 9, that is 3. So sum is this plus that is minus 2 times 12C3. First option is correct. So next problem. Next problem is problem number 38. Problem number 38 is coefficient of x to the power 16 in 1 upon x square minus x to the power 17. Coefficient of x to the power 17 in that options 30C24, minus 30C24, 30C25, and last option is 0. Plain, the problem is very simple. We have to find the coefficient of x to the power 16 in that expansion. Clearly, first first term will contain x to the power minus 2 into 17, that is 34, minus 34. After that, each term, coefficient of, power of x in each term will be increased by minus 2 plus 1, that is minus, 3. Then next term will be minus 31, then minus 28, then 3, minus 25, then minus 22. We have to find x to the power 16. Okay. Minus 22, then minus 19, then minus 16, then minus 13, then minus 13, minus 7, minus 4, minus 1, now 2, 5, add 3, 8, then 11, then 14, then 17. After that, it will increase by 3. So there is no power of x to the power 16. No power is there, x to the power 16. So the coefficient of x to the power 16 is 0, because there is no such term containing x to the power 16. So its coefficient is 0. So 0 our answer. Then 39. Problem number 39. The sum of coefficient of 3x square minus x minus alpha to the power 17 is equal to the sum of coefficient of alpha x square minus x minus 1 to the power 17. Then alpha is equal to 4, 3, 2, 1. The problem is, in that expansion, coefficient of sum of all coefficients of this is equal to sum of all coefficients of that. In that case, what is the value of alpha? Now we know that for any expansion, sum of all coefficients can be obtained by putting x is equal to 1. Very simple thing. X is equal to 1. So its sum of coefficient is 3 minus 1 minus alpha to the power 17. Similarly, the sum of all coefficients of that expansion is equal to alpha minus 1 to the power 17. And because its coefficient is sum of coefficient is equal to sum of coefficient. That's why it is equal to that. So we get 2 minus alpha to the power 17 is equal to alpha minus 2 to the power 17 is equal to minus of power is 17. So taking it 2 minus alpha to the power 17. So this is equal to that. So we must have 2 minus alpha to the power 17 into 2 is equal to 0. This cannot be 0, so that we have alpha is equal to 2. So answer is this, option C. Next, problem number 40. 40. If fourth term of 2x square minus 3 by x to the power n contains x, then fourth term is, once again, in this binomial, n is unknown quantity. Its fourth term contains x. Then how T4 is how much? Now actually T4 of that expansion is NC3 into 2x square to the power n minus 3 into minus 3 by x to the power 3. Oh, sorry. Options not yet given. Options are 1020x minus 1080x 1080x minus 1020x. The T4 is equal to that. After simplification, it is NC3 2 to the power n minus 3 into minus 3 to the power 3 into x to the power 2n minus 6 minus 3. As per our condition, T4, that is this, will contain x. So this is simply x, that is that power is equal to 1. So that we have 2n minus 9 is equal to 1. So 2n is equal to 10, n is equal to 5. Now T4 is this, now n is 5. So that it is equal to 5C3 2 to the power 2, 5 minus 3. This is minus 3 to the power 3 into x to the power 10 by 1, x to the power 1. X to the power 1, it must have x to the power 1. So that it is equal to minus 5C3, 5C, that's okay, into 4 into 27. It is equal to 5C2, that is 5 into 10 minus 10 into 4 into 27. So that it is equal to 4 into 27, 8. with negative sign into x. 0 for that. So our answer is this. Next problem. Problem number 41 now. If third term of one plus e to the power 4 log base e root over a whole to the power 4 is 3 by 8. Then second term how much? Given that in that binomial it's T3 third term is this, then we have to find second term. Now you see this is four options. Options are 1, 1 by 4, 2 and 3 by 2. So this one e to the power 4 log base e is a to the power half. So it is equal to e to the power log a to the power 2, base is e. So e to the power log a square base e is nothing but a square. So simplified value of the binomial is 1 plus a square to the power 4. Its third term T3 is equal to 4c2 into 1 into a square to the power 2, that is a to the power 4. So as per our condition, this is equal to 3 by 8. Therefore, 4c2 means 6. A to the power 4 is equal to 3 by 8. Gives a to the power 4 is equal to 1 by 16. That is a square to the power 2 is equal to, it is actually plus minus 1 by 4, but a square cannot be negative, not possible. So a square is equal to 1 by 4. Now we have to find T2. T2 is equal to, binomial is this, 4c1 into a square to the power 1. So that it is 4 into a square means 1 by 4. So answer is 1. So 1 is correct option, first option. Okay, let us stop today. I request you, if you feel that it helps you, then you please like it, share it, and subscribe it if not yet subscribed. Thank you.